So for our next talk, remember, stick around. If you have questions, put it in the chat box for both the previous talk or this upcoming one. Let us know if you have questions. Our next talk is Frederik, coming to us from KBC Group. So everyone, please, a warm virtual welcome for Frederik.
Hello, good evening here in Belgium to everybody. Thanks a lot for the opportunity to talk at the Neo4j conference, and I would like to tell my story of what we do at KBC. So I'm a full stack developer at KBC. KBC is a financial institution in Belgium, and I work there as a developer in the Innovation Lab. What do we do in the Innovation Lab? We are looking for new technologies, looking out and scouting for new technologies. And with those new technologies, we try to do proof of concepts, we try to do experiments in order to find business value for KBC. Okay, my slides are popping up, I think. Okay. Okay. So we're doing in this Innovation Lab all kinds of cool stuff, I think. We are investigating or doing experiments with blockchain, with cryptocurrencies. We are also looking at Solid from Tim Berners-Lee, doing some machine learning stuff. So all kinds of cool things. Today, I want to tell a story about two projects that we did, one about test automation and one about a data marketplace. The common denominator of those two is, of course, Neo4j. I want to do the talk on two levels. I want to explain functionally and on a business level what the value is of Neo4j and how we use it and what it meant for our project. But I also want to jump into some technical details and explain a bit more some algorithms that we did. Okay, so the first thing I want to tell is about a project that we did around test automation. It's called Probit, Pattern Research of Behavior and Intelligent Testing. When I started working at KBC, I was in the maintenance team, and the maintenance team for the KBC online applications, so the front, the customer-facing applications. And we were doing maintenance, and maintenance means you need to do incident solving, you need to do root cause analysis, and also you need to, or you're responsible for quality assurance. Quality assurance, what does it mean? The projects or the applications that you deliver on production, they need to be of high quality. If not, you're going to lose customers. So how do you do that? How do you assure this quality? You do it by testing, and testing a lot. You test this, or testing this costs a lot of money. It costs a lot of time. It costs a lot of resources. A lot of people are working on it. So in order to minimize these costs, you start doing test automation. And test automation, how does it look like? So if you have to have a visual equivalent of test automation, it's like this. So you have this closed environment where you place your software in, and you design these scenarios, these test scenarios, and you're executing the test scenarios in this closed environment on your software. If everything flags green of your tests, or the significant part of your tests, then you say the quality is good enough and the thing can go to production. But what do we see then, or what happens? The software is delivered to production, but things start to go wrong. And then your manager calls, and he or she says, how is this possible? I thought you did all the tests. And then we say, yes, of course. We have even the logs and the results to prove it, but still problems happen on production. So we started investigating and seeing why is this. It is because the user behavior on production environment is a lot more chaotic than what your tests are doing in your test environment. So users are not doing what you think they are doing. They do a lot more. And because of that, some context is kept over the screens when users are doing this, clicking back and forth, and then stuff starts to go wrong. Now, what does this have to do with graphs? A colleague of mine and I, we were working in the maintenance team, and then we went separate and we went our own ways within KBC. But one night we were discussing this in a pub over a beer, and we're saying, okay, hey, you know, the test automation, how can we increase this? How can we make the quality of the things that we deliver a lot better? We don't know, or we should be able to execute this behavior from production, what our users are doing. We should be able to do that in a test bot population. Can we do that? Can we do that? And we were thinking and discussing about it, and all of a sudden the bomb dropped, and we said, yeah, of course we can do that, because your front ends, and all the front ends, mostly all the front ends, they're packed with analytics tools. These analytic tools, all they do is just measure and capture what your users are doing. So we have this data. What if we could use this data and cluster out behavior and inject this intelligence, inject this behavior in our population of test robots, and let the test robots run freely in our test environment? That way, we create this living test environment, continuously applying behavior of production. So what does it mean? It means that you're automating your business as usual tests. So this was a nice idea, we thought. So we went back the next day and started pitching this in KBC, and it was picked up. But how does it, or why do we want to do that? So an example, say you have two users, user A, and the web application is an application to book a holiday. You have user A. He wants to do search for a holiday and wants to book a holiday. So, and now I'm going to why we are using graphs. So your front end is actually a big state machine. And in a certain place, when a user is in a certain place in your front end, he can choose a limited set of actions that he can do. So we can map this into a graph. For instance, user A, he wants to book a holiday. He clicks on a search. He inputs a value, say I want to go on holiday on Amsterdam. He searches it. He changes some properties about the trip, and he books his holiday. User B, it's a different scenario, and we want to separate that one. We want to separate them from each other. User B, he already has a trip, but he wants to change some properties. So he goes to his trip, he changes the properties, and then he saves it. Those are two different scenarios. It's different behavior, and we want to cluster this behavior and inject that in our test robots. That was the goal. Okay, so I'm going to dive into a little bit more technical now, how we did it, and Neo4j will come into the picture. So this is graphs. We knew that it's a state machine. We were searching for a tool or a database or whatever that could map this information and make it very accessible and very usable for us to inject that in our test robots. And then we came, the solution was Neo4j. So if we're going to have a look technically how we did it, still a bit high level, but okay. The user session contains these blue nodes, and the blue nodes are actions. And each action consists of yellow nodes, and the yellow nodes are attributes. So for instance, the first one, it's click on the button search, and search, it's a click on the button, the blue one, and the attributes are like the name of the button, search, the XPath expression, how long you clicked on the button, and so on and so on. And so you, when you stream data from the analytics tools to our application or our framework, then we get this tensor as an input for a user session. What we want to do now is try to calculate similarities between sessions and cluster and assign cluster names or cluster IDs to the sessions, so the behavior gets extracted in different subgraphs, if you will. We want to separate behavior in graphs. So what do we need to do that? We get this tensor and we want to make a vector out of it. And we vectorize it based on building a dictionary of n-grams of actions, and making sure that we converted them to a vector and normalize it so we can calculate distances. To calculate the distance, we use a cosine similarity. So we have this vector and we go over existing, or we are going to calculate the cosine similarity between this vector and the existing centroids. If none is found within a certain limit, if the distance between the centroid and the vector is not within a certain limits, we create a new centroid and create a new cluster ID for that vector with the same coordinates as that vector. So that way we identify the clusters and we split this behavior, and then Neo4j comes into the picture and we merge the original session into the cluster or a new cluster in Neo4j. That way we're getting in Neo4j aggregated behavior and we are losing PII information. For instance, if you're doing a transfer and a person is doing 10 euro and other persons are doing 100 euro and 50 euro, we start building as attributes of those actions distributions. So we have a distribution for the value that is inputted in this particular step. So we lose actually the information to get back to the original action. So we were building this and we were testing it. And we made sure we also built this test framework for our test robots, which was able then to ask to Neo4j, to our Neo4j application, give me a scenario that resembles production behavior. And based on probabilities, our Neo4j application returned the scenario to our test robots, and we could run a test bot population of a lot of test bots, actually bringing production behavior to our test environment. So this seemed to work. And when our test bots were executing these actions, we had this feedback loop implemented, where if an action was executed, okay, the action was flagged green. If not, the action was flagged red, and we knew then that we need to investigate the red ones to see if the error was legit. So we did that for the KBC online banking application, and it seemed like it was working. So we had something big. This made us very, very excited. And we went back to our management, because we were partly doing this outside hours and partly during the hours of KBC. And we said, this seemed like it was working, and we think there is a lot of value in there. So we were doing innovation, and we might have discovered something that could be really valuable, not only for a big corporate like KBC, but also for other big corporates that were also struggling with the same problem, like testing costs a lot of money, and especially your business as usual testing, because that's mostly the end of the chain. When you have your application and new functionality needs to be built in your application, that is tested pretty okay, because it's new, because your developer is testing it all the time, because your technical analyst is testing it, your functional analyst, then you have your acceptance testing, your business is testing it. So that's pretty well covered. But new functionality also has impact on existing functionality, and the existing functionality is mostly what is breaking, and that's the business as usual testing that should cover that. So it seemed like we had found a solution. So back to the management, and they said, okay, we need to think innovative about it, and we are giving you the opportunity to go to the incubator of KBC and found a spin-off of KBC. So this was a nice challenge. So we went to the incubator, and we gathered this team of 3 people. When you want to start your company, and now I'm going to talk a bit business and try to give some advice for people who are in the same situation. So if you start your company, you need to have a balanced team, and they say you need a hacker, a hustler, and a hipster. We were a bit unbalanced. We were with 2 hackers, 1 hustler, and no hipster, but we were going to manage. We thought we were going to manage. Other things that you need to do is, or you need to take care of, is your sales. Your focus needs to be right. Pricing needs to be right. Personally, you need to be balanced, and your budget needs to be under control. So our sales, we were spinning out of KBC. We were using KBC for warm leads, and our sales was pretty okay. When we started, we had 2 customers, and pretty soon we had 3 customers. We were targeting big corporates, so sales cycles to big corporates, they take very long, but we already had 3 customers, so that was fine. The next thing that needs to be okay is your focus. You need to be very focused, and you need to have a plan. Our plan was, we have this thing that is working, but it was very rough, and it was very technical to use. So what we decided to do is we sell this regression service externally. We sell regression service, regression testing, but we're going to use the tool ourselves, and we are going to make the tool more mature and automate stuff in the tool. So next thing that you need to have under control is your pricing. Our pricing, we thought long and hard about it. We had some questions, but we were doing sales, so it seemed like it was okay. It was suboptimal, but we were going to fix it later on. Personally, you need to be balanced. It takes a lot of work. I'm not going to say 24 hours a day, but it's very hard, and your family needs to be okay with that and support you, but that was all fine. And next, what you need to have under control is your budget. But because we needed to work or still work a lot on our application, because it's so technical, we need a lot of time, and we need a lot of more resources. But and more resources means more money. But we were in a situation with KBC that we could not ask KBC for more money. And we were also in the situation that we could not go outside for funding and investments to get more money. So we did not control our budget. And because of that, we needed to take action, and we shifted our focus. We said, okay, the product is not ready yet, but we think we can teach our customers how to use this, and we could push our product to the users, and then we can free up time to do sales, more money, more people. We could get this solved. So personally, it was getting really rough. And then my father got really ill, and then he died. So personally, I was not in an optimal form, and a colleague of mine, his wife decided to leave, so he was also not in a perfect condition. And that made us lose focus even more. And then in the end, because of all those things, our sales plummeted. And the customers that we had, they said, we don't use the tool anymore because it's too technical. The service that you were providing, it was perfect and it was nice, but now we don't want to extend the contract anymore. And that made us then fail the entire project, and it collapsed. So what happens then? Back to business as usual. I was a bit lost then, and I went back to KBC in the innovation lab, and Neo4j opened up so much possibilities, and I saw that, and I wanted to continue working in Neo4j, but there was no project. And then I met Annick, and Annick she's also working at KBC, and she's working in the big data team or the big data department. And her job is to go and look for data. Business integrators and data scientists, when they have a case that they need to implement, they come to Annick and they say the case is about, for instance, predicting house prices. What data is available externally, and can you give it to me? So they go to Annick, and Annick needs to design this 360 to get a complete view of the topic and go look for data. She needs to mail to procurement, she needs to mail to legal and compliance, and so on and so on, and it's a very manual process. And Annick says, it comes to me and she says, I want to automate myself. I said, that is a very good idea, and how do you want to do that? And she says, I want to do it like Gartner describes how big corporates should act or should do to go from an app-centric to a data-centric organization. I want to create a data fabric, she says. And I didn't know what the data fabric was, so she starts explaining it to me. She says, it's like this big knowledge graph which is connecting all the departments and activating this metadata and linking metadata together in order to get insights, valuable insights in what your company is doing, and so you can base your next decisions on data and not on a hunch. Gartner says, I said, okay, I hear connecting, I hear data, linking. So I said, oh, this is something that I can do with Neo4j. So I was completely in love with this, and we were going to try it. So what we were going to do is first bring this data into the picture and link cases with the data that is externally available, and also make this data catalog to make external data searchable. And we want to link these cases with this data, and we also want to link cost centers and profit centers with data, because the main reason that Annick wants to do this is because it's very hard to say or to say what the value is of data in a project versus the cost of the data. So we know what the cost is because the data providers are selling their data to us, so we know the cost, but we don't know exactly the value. For instance, if you have a project and they need a certain data set, it passes through procurement, and procurement says, this costs too much for that project. We don't want to do that. It's too much. And then the next project comes, and they have the same question for the same data set, and procurement does the cycle again, and they say, no, it costs too much. And that way, we are missing out on valuable business projects. So it is a hard problem to solve. If we could link those things together and make it searchable and make it visible, that's one step towards solving this problem. So we also want to integrate, because it's a knowledge graph, integrate all the departments. We also want to, step one, integrate the procurement and legal workflow into this picture. So that's what we did. So we started this experiment again from within the innovation lab, and I used Neo4j Aura to start building this knowledge graph, where Annick defines some concepts that she uses a lot. So she start building this ontology. We build it in Neo4j on top of Firebase, make sure that external data providers can link or can log in our application and put data sets that they have for sale in our application, so it can be searchable. Annick also wants, she designs this knowledge graph, this knowledge graph based on an ontology of concepts and themes. And she wants to provide data scientists and business integrators a way to do an inspirational search, like she does by designing this 360. This needs to be automated. So how do we do it? We define these concepts and themes and make them clickable, and let the data scientists and business integrators jump into the graph and search and navigate through the graph to see what things are related for their topic. For instance, the house pricing case, you can go and look for addresses. You can go and look if the address is in a decent area or not in a decent area, if it is subjected to flooding, so if it is related to risk areas and stuff like that. All that can be navigated through the thing that we created. You see visually what data sets are available for that. You also see which data providers are available for that, and you can start the workflow from within this this application. So we're starting to integrate everything. Our first step to becoming a data centric organization. Now, this is a bit what I wanted to say functionally and the value of it and what it can mean for KBC. Now I just, to conclude, want to go over two things that made us gain a lot of speed by using Neo4j. So we were starting this experiment, and there was this necessity to do this search, an intelligent search, and I could have implemented it with Elasticsearch, but I'm so head over heels in love with Neo4j, and as it was an experiment, I say, let's just go for Neo4j and start building this in Neo4j. How did we do that? We link, or when a user does a search contains sentences, and we start storing the searches and start matching the searches against our knowledge graph and against the data that is available in this knowledge graph. by physically linking the search to the real data. This means that when searches or words are reused, then we just follow the relations that exist and we just get the results very quickly. The benefit also for doing this is, like our next question is, what are our users searching for? This is a simple query to just know what are popular searches, what are searches that are popular that don't find any results. And that way we know what we need to focus on to get some data, which data is missing in our system. We have these 20,000 data sets that are open data sets available in Flanders and Belgium. But next to that, we also have data sets from data providers that they put in our system. So we can go and look, is there data that is not in our system that our users want to know? So visually, to implement this is really easy and made us gain a lot of speed in the experiment, which is still going and getting traction. So visually, how does that work? You have your search, is the red node, and it contains a sentence, which are the blue nodes. And what you're searching for is actually the center nodes that are matched against those words. Another thing that we implemented and was also very easy to do by means of Neo4j was recommendations. So we offered the possibility to our data providers to insert their data sets themselves, but they need to match or need to be linked to the ontology, or to the semantics and the knowledge graph that we have in our application of concepts and themes and spatials and so on and so on. So we need to map them against that. How we did that is when they input their data sets, we give them the possibility to label the data sets themselves. So it's free text that they input. And because there are already a lot of data sets in our application, we just go look how does these labels match against the concepts and the themes that are defined in our knowledge graph. So again, this is really simple. It's just going for all the labels that you assign to your new data set, go over the existing data sets and look for the themes or whatever, and order them based on occurrences. So that way you know which ones are the most popular and which ones you need to return. For instance, if we create a new data set with and we label it with these 3 yellow nodes, the 3 yellow labels, actually what our system needs to return as a suggestion is the one in the green. How does the query work? Very easy. For this label, it goes and looks which data sets are connected. For that one, for the pink one as well, which data sets are connected with what, and then for the yellow, for the red one as well, which data sets are connected with which teams. And this one is the most high ranked, and this one is the one our system should return. So this is really easy. It makes your suggestion engine, if I can even call it an engine, it makes it pretty accurate and it works pretty nice. So to conclude, we used Neo4j, and Neo4j made us gain a lot of speed in this innovation projects that we do. It has a lot of possibilities. You can map test automate or user behavior from what is happening on production and inject that in your test robots. Although the project failed, it was not because of technical reasons, it was because of organizational reasons. So it offered us a lot of possibilities. And for the data fabric that we are creating, it's still ongoing. It's getting traction now, and management is convinced that that is the way that we should go. And that is because we could take these quick steps because of the structure and the flexibility that Neo4j provides.